Now that we spent time learning the main types of networks, let's talk about something students hear all the time in networking: topology. A network topology is basically the shape or layout of how things are connected. In this lesson, we are focusing on physical topology, which means the real connection layout: who is connected to what, and what that layout looks like in the real world. So today, we're going to make several common topologies feel simple: bus, star, ring, mesh, and a few other layouts you should recognize. A good beginner way to think about physical topology is this: it is the shape of the wiring or physical connection layout. A physical network diagram is used to understand the physical components of a network, where they are placed, and how they are physically connected. Here's a very useful rule of thumb: physical diagrams follow the flow of the wires, while logical diagrams follow the flow of the packets. So if we are talking about physical topology, we are not mainly talking about IP addresses or traffic decisions. We are talking about the real connection pattern. Is everything tied to one central point? Is everything arranged in a loop? Is everything hanging off one long line? Are there lots of possible paths? That is the big idea. Topology matters because the shape of a network affects how the network behaves. Different layouts can affect things like how easy the network is to build, how easy it is to expand, how much wiring it needs, how failures spread, and how much resilience the network has. So, topology is not just a drawing style, it helps explain why one network design may be simple and cheap, while another may be stronger and more fault tolerant. Let's start with the bus topology. A bus topology is a layout where all hosts are attached to a single long wire, traditionally coaxial cable. In early Ethernet, everyone was sharing the same medium. Because only one host could transmit onto that shared wire at a time, devices had to check whether the wire was already in use before sending. If two hosts transmitted at the same time, a collision happened. That is where Ethernet's older carrier sense multiple access collision detection, or CSMA-CD, behavior came from. So, in plain English, a bus topology is like one long shared road that everybody is trying to use. That makes it simple to picture, but not ideal for modern networks. And one very important point to note: real world deployments no longer use bus topologies. Next is the star topology. A star topology is a layout where each host or connected device links directly to a central device, such as a hub, switch, or router. So instead of everyone sharing one long cable, every device has its own separate connection back to the center. That makes the star topology much easier to picture in modern terms. If the bus is one long shared line, the star is more like spokes coming into a hub. This is one of the most important topologies for beginners to understand because it connects very closely to how many real networks are built today. Now, here's an important detail. Older star layouts use a hub in the center, which repeated signals out to every other port. But replacing that center hub with a switch or router broke up the electrical circuit and helped move Ethernet into a more modern design. So, when most people picture a small office or classroom network today, they are usually picturing some form of a switched star, devices around the edges, and a switch in the middle. That is one reason the star layout is so important. It is a very practical, very common, real world shape. Now let's look at the ring topology. The ring topology was previously discussed in the WAN lesson. Devices in the ring are connected in a circular path. One major advantage is resilience. The ring is a two connected topology, meaning there are at least two paths through the network. So if a single router or link fails, traffic can still reach the remaining destinations. That sounds great, but there is a trade off. As more nodes are added to the ring, available bandwidth to reach a destination decreases, and additional nodes can also add more delay and jitter. So, in beginner terms, a ring is good because it gives you another way around, but it can also become more crowded and less efficient as it grows. Another important layout to recognize is hub and spoke. A hub and spoke is useful because it can support many end locations with a relatively small amount of wiring, especially in dense areas. But there is a downside. In a single homed hub and spoke design, one failed hub or one failed link can interrupt service because that central point becomes a single point of failure. A dual homed version improves resilience, but it is more complex. A simple way to picture hub and spoke is this: one main center with many outer locations depending on that center. So, if star is often used to describe local device to center layouts, hub and spoke is a useful way to describe larger designs where many locations rely on central connection points. Now, let's talk about mesh, specifically the Wi Fi mesh. It consists of multiple Wi Fi access points connected through a backhaul to create a mesh. At a beginner level, the easiest way to think about mesh is this: instead of having just one simple path, a mesh is built around the idea of multiple connection paths. So if a star feels like everything goes to the center, mesh feels more like there may be several ways to get across the network. That does not mean every device must connect to every other device in every case. The big mental picture is simply more than one possible path. And that is why the word mesh often makes people think of stronger coverage, better flexibility, or better resilience. Let's make all of this easier to sort out. A bus topology is one shared line. A star topology has devices connecting to one central point. A ring topology forms a loop. A hub and spoke topology has many outer points depending on a central hub. A mesh topology focuses on having multiple possible paths. So the real trick is not memorizing the words by themselves. The trick is attaching each word to a clear picture in your head. Once you do that, the topic becomes much easier. Let's clear up a few beginner misconceptions. First, topology is not just a fancy diagram word. It describes something real about how a network is arranged. Second, physical topology is not the same as logical topology. Physical diagrams follow the wires, while logical diagrams follow packet flow and control behavior. Third, one topology is not automatically best in every situation. Different layouts solve different problems. Some favor simplicity, some favor resilience, some reduce wiring, some improve alternate path options. That is why learning topology is really about learning design trade offs, not just memorizing pictures. So let's wrap this up. A physical network topology is the real connection layout of a network. It shows how devices and links are physically arranged. In this lesson, we covered the main pictures you want to remember. Bus equals one shared line. Star equals everything connects to a center. Ring equals a loop. Hub and spoke equals a center with outer branches. Mesh equals multiple possible paths. And most importantly, these topologies matter because they help you understand how networks are built, how they grow, and how they handle failure. That is why topology is part of the CCST objective set and why it is such an important beginner topic.